Okay, let's look at the example. It says to write a rule for the arithmetic sequence and then use the rule to find the 50th term. So when we write the rule, we don't just say subtract 7. Like, that's not the rule we're looking for here, but it's part of the rule because subtracting 7 means that D equals what number? Negative 7. And if you don't look at it and say, oh, I'm subtracting 7, so D is negative 7, the other way you can do it is you can just subtract the second one minus the first one, and that will give you a D of negative 7. We're going to use that negative 7 in the rule. The rule is also going to use the formula from the front of your notes. So A sub n equals A sub 1 plus n minus 1 times D. So A sub n and n will stay variables. I have D, and I need A sub 1. What's A sub 1 going to be? The first number. So in this case, 27. Okay? So A sub 1 means first term. And it's 27. And so when I write the rule, you have two variables. The first variable is A sub n. That means the nth term. And then you're going to put in 27 plus the second variable is n. And then even though the formula doesn't show parentheses around the D, I usually put parentheses on it so I remember that I'm multiplying by negative 7 and not subtracting the 7. Then it says use the rule to find the 50th term. So this is the rule. This is part of your answer. And then the second part is to find the 50th term, which would be A sub 50. And you're going to substitute in 50 for your n. Okay, and I haven't done that yet. Anybody do this and get an answer? Negative 316? And Sydney and Jennifer, did you get negative 316? You didn't do that part yet? Okay. And Tabitha, did you get that? Negative 316? Okay. So equals negative 316. If you guys didn't grab a calculator yet, go ahead and grab a calculator. All right, so we can box that one up too. So we had two different answers because it asked for the rule and then it asked for the 50th term. Okay, so then I said today we're going to talk about multiplying patterns. Geometric sequence is a sequence where the ratio between each term is constant, which means that each term is multiplied by the same number. This ratio is called the common ratio. So you notice here how we subtracted to find the D value that we were adding each time. We were adding negative 7. When we have a geometric sequence, we can divide the second by the first to find this number, the common ratio. Sometimes you can just look at the pattern and you can see 2, 8, 32, 128, that we're just multiplying by what number each time? Yeah, 2 times 4 is 8, 8 times 4 is 32, 32 times 4 is 128. So if you can see it, that's fine. But if you can't, what you can do is you can divide the second term by the first term, 8 over 2, to find 4. And then you can see that each time we're just doing times 4. Times 4. Times 4. Times 4. Okay, so the first question was just asking, what are you multiplying by each time? And it was just 4. All right, example 2 says a geometric sequence has a first term, a sub 1 equals 3, a common ratio, r equals 4, and it says use the rule to find the sixth term of the sequence. So let's go back now and look at these rules. We kind of skipped over them. This one starts with u sub n, and this one starts with a sub n. Besides switching the a for the u, is there anything else that's different in these two rules? Besides switching a for u, is there anything else that's different? No. They're actually the same rule. So remember for the sum, last class, for the sum we had two actual different rules. These are not different rules. These are the same rule. And we actually use in Algebra 1, we use this notation here. Okay? This one is what they use in IB. And honestly, it's the same exact rule. There's nothing's changing here. We just changed the letter A to U. Okay? So I'm going to continue using this one, but if you signed up for an IB math class next year and they say U sub n, don't be confused. It's the same thing. They just changed the letter. Any questions on that? Okay. So what I want you to do now is take this rule and you're going to find the sixth term. So that would be A sub 6. And you're going to use this rule to find it. So take a minute and do that. Okay. So A sub 1 is my first term, and they told me what it was. And then R is 4. And then n minus 1. So the sixth term, that means that n is 6. So it's going to be to the 6 minus 1. Okay? Now, if I want to do this on the calculator, you just want to put in parentheses around your exponent. So we have 3 times 4 raised to the, oh, I didn't need parentheses because it went up like that. But if it doesn't go up like that, then you'll do parentheses. And 6 minus 1. All right, I'm getting 3,072. Anybody else get that? Good. Okay. Okay. I'm going to have you do example 3, and there are 2 ways you can approach it. We had something like this on our notes last class too. To find the first 5 terms, you could literally put 1 in for n and get an answer, and then put 2 in for n and get an answer, and then put 3 in for n, and it works. It just takes time. The other thing you can do is compare this to the formula here. Just one sec. So the other thing you could do is compare it to the formula and realize this is my first term. And this is R, the number that I multiply by each time. So I know the first term's 2. I can multiply by 5 to find the next term, multiply by 5 to find the next term. So it's up to you. 2 approaches. 1, just put in 1 for n, then 2 for n, then 3 for n, then 4, etc. The second thing is to use 2 for your first term, and then just multiply by 5 each time to get your next terms. All right, 2 methods. The long method was to find each value. So you put in 1, so you would say A sub 1 is 2 times 5 to the 1 minus 1. And A sub 2 is 2 times 5 to the 2 minus 1. And A sub 3 is 2 times 5 to the 3 minus 1. And you get the idea, right? You would do that for 4 and for 5. And you would get your values. This one would give you 2. This one would give you 10. This one would give you 50, right? But another way of doing it is to realize that your first term is 2. And the reason I know my first term is 2 is because it's right here in the formula. And the formula says that is A sub 1. So that is your first number. So the other way to do it is say my first number is 2. And then since R is 5, to get the next number, you do times 5. So I do times 5 to get 10. And then I'm going to do times 5 again to get 50. And then what's the next one? 250. And then? Yeah, 1,250. So both of the methods work. If you really like one method over the other, you can do that. It's good to understand both methods, though. Any questions on that one? All right, write the geometric sequence given that the fourth term is 24 and the ratio is 2. So to write the geometric sequence, we need to go back and find a sub 1. And the one thing I have to look up right now is I don't know if they want you to write the rule or if they actually want you to write terms of the sequence. It's going to be one or the other. So I'm going to look up which thing they're doing, but here's what I want you to find now. I want you to think about how do you find a sub 1? So if you know the fourth term is 24 and you know that the ratio is 2, then how do you find a sub 1? All right, so when we know that 24 is our fourth term, 1, 2, 3, 4, 24 is the fourth, and the pattern is multiplying by 2 each time, you can divide by 2 to get the one before it, divide by 2 to get the one before it, and then divide by 2 to get the one before it. So you can see that your first term, a sub 1, is 3. And then it already told us that the r is 2. So this should be all we need to know in order to write our formula. I'm going to copy the formula here. And then I'm going to rewrite it using 3 for a sub 1 and using 2 for r. A sub n equals 3 times 2 to the n minus 1. And that's it. All right, who has a question? All right, so we're on the back now, and we're finding the sum of the geometric series. It's called the sum of a finite geometric series. Finite is the opposite of infinite. So infinite means that it never what?
Ends.
Never ends. And so finite means it does end. All right, so like you could find the sum of a geometric series with 100 terms. It has an endpoint after the 100th term. There exists something called an infinite geometric series, and we will get to that, but right now we're doing finite. I want you to tell me about the two formulas at the top. Are these two formulas the same or different?
Different.
What's different about them?
The N and A and does not equal 1.
Okay. So this part over here, the r does not equal 1, that's just saying that you can't have a denominator of 0, right? Because you guys see how the 1 would make your denominator 0? Yeah. So you can kind of ignore that, because why would we ever make the r 1? Why would you have a pattern where you're multiplying by 1, right? The pattern would be like 5, 5, 5, 5, 5. That wouldn't make any sense. So you can kind of ignore that, if that helps you at all. The only other thing that's different, though, is that you have A and U, right? So the U is what the IB uses. The A is what we use. So this one is for IB, and this one is for us. You don't need to worry about the R doesn't equal 1. The only thing you need to know about that is don't be confused by it. So when you see it on a test, if they give you a formula and it says R doesn't equal 1, be like, okay, that makes sense. I don't need to worry about that now because R is not going to be 1. This is our formula. So the sum is equal to the first term times 1 minus R to the n over 1 minus R. We're going to use that to find the sum of the first 10 terms of the geometric series. So you need to figure out which number is a sub 1 and which number is R, and then you need to use the formula. And I'm going to have you guys start right now. So we had to, in order to use this formula, we had to identify a sub 1, R, and n. So a sub 1 is your first term, and it was only tricky because they hid it up here on the previous line. Your first term is 2. Your R is how much are you multiplying by each time. And some of you can just see that you're multiplying by what number? 5. And that's fine. If you see it's 5, you can just write 5. But if it was tricky, like if they had fractions in there or something, then I would do the second divided by the first. So 10 divided by 2. That would give me R of 5. And n is the number of terms. And it says find the sum of the first 10th term. First 10 terms. Pardon? Oh, is it frozen? It sure is. Thanks for being the only person to tell me. Okay, so a sub 1 your first term. R is the number you multiply by each time. If it were tricky, you would divide the second by the first. And n is the number of terms. And now we're going to use the formula. Turns out the calculator is a little bit tricky too. So 2, 1 minus r, so 5, to the n, 10. And then notice the parentheses on the denominator. You need those parentheses. 1 minus 5. This one doesn't have it for some reason. That's weird. It should. Okay, so when you put that in the calculator, I'll show you what it should look like. It should look like this. You could put another set of parentheses around your numerator just to be safe if you wanted to. It wasn't necessary this time, but sometimes it's going to make a difference depending on how much you have in here. So any questions on the buttons to push to get exponents or parentheses? All right. So I'm getting 4,882,812. You got that too? Okay. I think we have one more. But it's also short. I don't know. I mean, it's different. It's different, although you have good background information on it because you've studied it before. Mm-hmm. Yep. All right, suppose you go to work at a company that pays you 1 cent for the first day. Anybody looking for a summer job? Nobody started thinking about a summer job yet? Yes. So would you take this job that pays you 1 cent for the first day?
No,
But then they pay you 2 cents for the second day.
absolutely not.
And then they're going to pay you 4 cents for the third day. All right, some people are saying yes, because they have heard about this deal before. So every day your wage doubles, and here's the rule for this sequence. Notice a sub 1 is 1 cent. That was your pay on the first day. The 2 is, the R is 2 because you're doubling it, so you're multiplying by 2. And we heard some yeses and some nos on would you want this job. It says, what would your total income be if you worked 10 days? So that means n is 10. So we would do a sub 10, 0.01 times 2 to the 10 minus 1. Go ahead and find your income for the first 10 days. See if that convinces you if you should take the job or not. Oh, you know what? Guys, I used the wrong formula. I think the reason I used the wrong formula is because it was right here. But what is it asking me to find? What word did I forget to look at? Total. So total means I should be using the sum formula, right? My bad. That would tell me my pay on the 10th day, but that's not what I'm looking for. I'm looking for a sum. So let's do this one. S sub 10. And then first day. One minus R to the 10 over 1 minus R. All right, for this one I'm getting $10.23. Did you guys get $10.23?
Yeah.
All right, so would you work 10 days for a total of $10.23? No, unless you know what's coming, right? Because we're going to find the pay for 20 days now. So S sub 20. So you literally just need to change your 10 to a 20. Layla, what was your answer for on the sum of the first 20 terms?
$10,485.75.
That's what I got. All right, would you work 20 days for $10,485.75? Yes, so this pay scale starts off kind of cheap, but it ends up paying a lot. And some of you may want to experiment with what happens when you put in a larger number for the number of days, because you do end up getting a whole lot of money on this pay scale. So if anybody ever offers you this, make sure they actually have the money to back it up and then take it. Okay.